Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at troubleshooting wireless LAN issues. We'll be discussing troubleshooting approaches, wireless client not connecting, troubleshooting when the network is slow, and updating firmware. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. As you're working with wireless LANs, you're always going to have a problem. There's going to be all sorts of different issues that pop up that are causing your end users not to connect or connect in slowly. Just a whole lot of different stuff. It can be pretty simple or it can be pretty complex. It goes the spectrum. It can be hardware, software. It can be connectivity issues. The best thing I can tell you for troubleshooting this is to take your time to think about the process. Sit down, analyze what's going on, and then determine that. Use a systematic approach on your troubleshooting. Don't use what we typically call the shotgun approach. Go in there, try and change 8 different things at once, and then see if that works. Take an approach that is systematic, that goes through and looks for a problem, that helps you identify it and taking a step at a time. A lot of times, this is a method that will work typically quicker than just going in there and making a bunch of changes and seeing if that works. Plus, when you do a systematic approach, you'll understand what was wrong, what you did to fix it, and hopefully you can correct future problems. Now, one of the most common and efficient methods out there for troubleshooting is based upon the scientific method, going through those principles there. Here's a 6-step approach to troubleshooting. First thing is identify the problem. Now, identifying the problem is not necessarily listening to what your end user is saying. You may have a wireless issue, but what the end user is reporting to you is the internet's not working. Well, that could be a lot of things on your network, from a problem at the ISP to your core network being down to your DHCP server to everything there. And so you need to actually identify what is causing this problem, narrow it down. Once you figure out what's actually causing the problem, let's figure out a theory. Let's come up with an idea of why this is happening. Then test that theory. I think it might be this problem. If I take that out of the equation, or if I connect in differently, if I fix that problem, it'll do that. Let's establish a plan here of action to resolve and implement a solution so it doesn't happen again. Go ahead and think about, okay, if this is always happening, what can we do to stop this in the future? This is something where if you spend a little time up front fixing the problem, diagnosing it, figuring out, implementing a solution, is probably going to save you a lot of headaches down the road. Then once you have everything up and going, go back and verify that everything is working correctly. Just because you fixed one thing that you thought might be wrong, the real issue might have been something else different and you may not have fixed it. So go back and verify that you actually fixed the problem. And then the last step is document. This is typically one of the last things that get done. Typically, this step gets skipped a lot because you don't have time. You have another fire to put out. As the administrator, you have to go and fix something else, and you don't have the time to document it. But if you're like me, after I fix a problem the first time, the second time, the third time, it really starts to bother me that I have to spend all this time figuring out what the problem is, researching it, how to fix it. I like to document my stuff right away. I like to document my findings, my observations, figure out what did I do? Did it actually fix the problem? That way, when that problem pops up, I can go back in my notes, I can look and see what I did, and I can fix that problem. And if what I did last time doesn't work, maybe we'll try a different approach. So this documentation is a very important thing, but it's like comments when you're writing a computer program. A lot of times you just don't have time to put it in. But take the time, make sure you document it. It will help you in the long run. One of the big things is when your wireless clients don't connect. When your wireless clients don't connect, the first thing I look at is I look at the end device. I make sure it's configured correctly. And the end user, yes, they will say, yes, it's configured correctly, it's all set up, but for me, I personally like to go there and look at it and make sure it's set up. My experience, I find that that end device is not configured correctly a lot of the time. That makes a lot of the troubleshooting done very quickly and looking at that. Once you verify that, then start pinging IP addresses. Ping something local to make sure that you can at least get that wireless connection, and you can ping the default gateway or maybe the wireless LAN controller, the routers, DHCP server. Ping something on your local network to make sure it's there. If all else fails, a lot of times reloading the driver helps. Either reloading or updating that driver. They come out with fixes and patches and ways to make those wireless clients work better, looking at that driver. If it still doesn't work, start looking at your security modes and encryption. Make sure it's set correctly. Most operating systems auto-identify whether you're using WPA, WPA2, pre-shared keys, 802.1x. May not be automatically identified, may not be identified correctly. Somebody may have went in there and made a change to the settings. Make sure that is all set up. Of course, then we have it's operational. They can do everything on the network, but it's really slow. And so what you need to look at is, are they actually outside the plan area of coverage? Well, inside your building, you have good coverage. Outside the building, you don't want the coverage, so you purposely don't have coverage out there. But this employee, when they go out on their break, they can't surf the internet on their phone because they don't get a good Wi-Fi signal from you. Well, this is planned. You don't want your Wi-Fi coverage to go outside. So you need to check and make sure how they are on their coveraged area. Then start looking at stuff like the channel settings to make sure they're on the right channels. If the wireless access point is broadcasting on one channel, the client's set to another, stuff is not going to work. Maybe you have a couple access points for some reason that are set on interfering channels. Different things to look at, different ideas there. And then always check for interference. Environmental issues can usually allow operation to happen, but it will slow down the speed, it will slow down the performance a lot. Whether it's looking at what types of walls, is it a wooded studded wall, a steel studded wall, or a concrete brick wall? Those allow signals through differently. Well, the signal's been working for years, but all of a sudden it quit. Well, maybe you're outside and the bushes have grown up over time, and those bushes have now stopped the signal from going through. I've seen that happen several times. So look and see, is there interference that's happening where your radio signals are going? Could it be a physical issue? Something happened to your antennas. One of your antennas got turned down. A storm came through and ripped off one of your wireless antennas. The one I love is there actually power to the device, and is it turned on? I have troubleshot a couple of times in my life where I've spent a long time and the device just is not responding and it's not working, and I come to find out it's not turned on. Somebody turned it off. In my head, it's like, why would somebody turn it off? Nobody should ever turn it off, but yet they did. And for me, assuming that nobody would ever turn it off, that cost me a lot of time. So go ahead and look and make sure it's powered on. Look at those links. Look at those cables running to your access points, to your wireless LAN controllers. Make sure that they're there. Make sure there's some link lights on there saying that, yes, we do have that. Make sure that you're wired in correctly. Send out some pings. Make sure you can ping all of your devices. Make sure your devices can ping each other. Make sure your wireless LAN controller can ping your access points, so that they have a communication path, that the switches are set on the right VLAN. Make sure that your wireless LAN controller can ping your 802.1 authentication servers, your radius servers. Look at your access point configurations. Maybe there's a setting in there. You can then start investigating the performance issues and power statuses of your access point. You can start getting into more advanced topics. I hope you're liking this episode on troubleshooting wireless LAN issues. If you have the time, please leave a comment and let me know what you think about troubleshooting wireless LAN issues. You can also visit my website at KevTechify.com. There you can find out how to get all these episodes in video and podcast form. One suggestion I can give you to help increase your throughput, especially when the network is slow, is to optimize and increase the bandwidth of your dual band routers. A lot of routers nowadays operate in the 2.4 gigahertz and the 5 gigahertz. They're separate radio transmitters and receivers, so they're separate. Each of those send out their traffic. They don't interfere with each other, so they can communicate simultaneously. One of the big things to help increase your throughput and speed up your network is to actually upgrade your wireless clients. You just went through and put all new access points in, but you didn't upgrade your clients. And getting an upgrade to those clients, whether it's in your laptop where you go in and actually change that wireless card or just buy them a USB adapter, using those new technologies, that's going to increase their bandwidth through that wireless connection. And a lot of times, make sure you split your traffic. Make sure you have half of your users using 2.4 gigahertz. Make sure you have half your users using the 5 gigahertz. If everybody's on the 2.4, it's going to be slow. Why not use both of those radios? Now, a couple reasons to use this split traffic approach. The 2.4 gigahertz, that's the first one. That's the basic internet traffic. I typically send my basic internet traffic over that. That's browsing web pages. If it takes a half a second or second longer to load, that's fine. That works. That bandwidth still could be shared. Now, it used to be said that the 5 gigahertz was much less crowded. A lot of devices didn't use 5 gigahertz. A lot of people didn't know about it. But over time, people have heard that. And so when people say use the 5 gigahertz because it's less crowded, well, end users are starting to see that it's a faster network. They can get better throughput there. But it is less crowded than the 2.4 gigahertz. Remember, microwaves, wireless phones, they all operate in the 2.4 gigahertz, and so they're causing interference. Moving to the 5 gigahertz gets away from some of that interference. Plus, 5 gigahertz has more channels. They have 8 usable channels, where 2.4 gigahertz really only has 3 usable channels. And so there is much more room in the 5 gigahertz, and that's why they say 5 gigahertz is less crowded. By default, a lot of access points, they operate both on the 2.4 gigahertz and the 5 gigahertz, but they name those networks the same. And when you pull out your smartphone and you see the name of that SSID, you don't necessarily know if you're connecting into the 2 gigahertz or the 2.4 gigahertz or the 5 gigahertz. My suggestion is go in and rename them. When I set up a router that's got, an access point that's got both 2.4 gigahertz and 5 gigahertz, I go in and I rename those SSIDs. I rename them and somehow signify that one is the 2.4 gigahertz and the other one is the 5 gigahertz. A lot of times I put the number 24 and the number 5 at the end just to signify that. Sometimes I put 24 gigahertz because you can't put a decimal point in there, so it's 2.4 gigahertz, and then you put 5G at the end. And I always get the people that look at that and say, oh, it's 5G, it's the cellular network. No, it's just the name of it. This SSID is using the 5 gigahertz. When you change those names to easily identifiable, then you can tell your users, if you're connecting with a smartphone, go ahead and use the 5 gigahertz. It's going to be faster for you. And so that way you can start load balancing. You can take all your other wireless devices and you can start load balancing between them. Also, where you put your access points, pay attention to the surroundings. Make sure there's no obstructions. Put it in the center of the room. Don't put it in a corner behind the file cabinet, because that file cabinet is going to block all the signals going through. So look at that. Make sure that there's nothing blocking your signals. And if you are having problems, use some sort of Wi-Fi range extender, or even they have Powerline Wireless, where you can use the existing electrical wires in the walls to extend your wireless. And that's a pretty cool technology, and it's a certain use situation, but it might help you in some places to extend your wireless networks. And one of the last things to help you keep your wireless network up and running and efficient is to update your firmware. When you're using something like a wireless LAN controller and lightweight access points, it's a pretty neat system and it happens pretty good. What happens here is the wireless LAN controller, you update the new firmware that you want to push out to all of your access points. You upload that to the wireless LAN controller, and then the wireless LAN controller takes care of pushing that new image, that new firmware out to all of your access points. You don't have to do that. And so this is another administrative task that has been made really easy to do with how the wireless LAN controller works with those lightweight access points. A review for episode 13, wireless LAN configuration. Remote workers, small branch offices, and home networks often use a wireless router, which typically include a switch for wired clients, a port for an internet connection, sometimes labeled as WAN, and a wireless components for wireless clients to access. Most wireless routers are pre-configured to be connected to the network and provide services. The wireless router uses DHCP to automatically provide addressing information to connected devices. Your first priority should be to change the username and password of your wireless router. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add an wireless access point. The router will use a process called network address translation to convert private IP addresses to internet routable IP version 4 addresses. By configuring quality of service, you can guarantee that certain types of traffic, such as voice and video, are prioritized over traffic that is not time sensitive, such as email and web browsing. Lightweight access points use the Lightweight Access Point Protocol to communicate with a wireless LAN controller, a WLC. Configuring a wireless LAN controller is similar to configuring a wireless router, except that the wireless LAN controls access points and provides more services and management capabilities. Use the wireless LAN controller interface to view an overall picture of the access point system's information and performance, to access advanced settings, and to configure a wireless LAN. Simple network management protocol is used to monitor the network. The wireless LAN controller is set to forward all SNMP logs, called traps, to the SNMP server. For a wireless LAN user authentication, a radius server is used for authentication, accounting, and auditing, AAA services. Individual users' access can be tracked and audited. Use the wireless LAN controller interface to configure SNMP server and radius server information, VLAN interfaces, DHCP scope, and WPA2 enterprise wireless LANs. When troubleshooting a wireless LAN, a process of elimination is recommended. Common problems are no connectivity and poor performing wireless connection when the PC is operational. To optimize and increase the bandwidth of an 802.1 dual band routers and access points, upgrade your wireless clients, and split the traffic. Most wireless routers and access points offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers, as well as security vulnerabilities. You should periodically check the router or access point for updated firmware. It was my pleasure to provide you with this wonderful episode on troubleshooting wireless LAN issues. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.